when we pass arguments to methods in C#, by default they are passed by value, which means a copy of the variable is passed to the method. For value types, a copy of the value itself is passed to the method. While for reference types, a copy of the reference to the object is passed to the method. To change this behavior and pass arguments by reference, we can use parameter modifiers. By applying one of these modifiers to a parameter declaration, we can pass arguments by reference instead of by value. In this lecture, we'll discuss the modifier. Hello guys, good to see you again. Okay, the modifier in C# is similar to the ref modifier. When we use the modifier for a parameter, it means we're using the pass by reference technique. Similar to ref, if we have a parameter with the modifier, it must have a value assigned to it before we call the method. Alright, in C#, there are two important differences between the ref and in modifiers. First, with the ref modifier, the method is allowed to assign a new value to the parameter. This means that the method can change the value of the argument that is passed to it. On the other hand, the in modifier means that the method can only read the value of the argument. It's not allowed to write or change the value of the argument. For example, in this code, we can use both ref and in modifiers to read the parameters. However, if we try to write or assign a value to the parameters declared with in, we encounter an error, because they are declared with the in modifier. On the other hand, we can easily assign a new value to the parameters declared with ref. So, ref allows both reading and writing of the parameter's value, while in allows only reading. Alright, another difference is that when passing arguments, for a ref parameter, the argument must include the ref modifier, while for an in parameter, the in modifier is optional. This means that in the calling method, we can simply provide the argument without any modifier. Alternatively, we can use the ref modifier on the argument. However, if we choose to use ref instead of in, the compiler will issue a warning to notify us. Alright, let's take a look at the in modifier in action. As we mentioned earlier, the in modifier is required in the method declaration, but unnecessary at the call site. So, we need to include the in modifier in the method signature. Okay, as we said, when calling the method, using the in modifier is optional, so we can simply provide the argument. Or like here, we can use the ref modifier instead of in. Okay, as you can see here, we encounter an error. The reason is that we're trying to assign a value to the parameter, but as we said, when we use the in modifier, the parameter becomes read-only, meaning we can't change its value. Okay, let's remove this line of code and run the application. As you can see, even though we use the ref modifier in the method call, we get the correct result. Now, let's remove the ref modifier in the method call and run the application again. As you can see, we get the same result. It's important to note that, even though specifying the in modifier in the method call is optional, it's recommended to use it both in the method signature and the method call. Okay, let's discuss why it's considered a best practice to include the in modifier in the method call. But before we dive into that, it's important to understand that we use the pass by reference technique when we want to avoid passing a copy of the variable. This is especially helpful when dealing with large value type arguments, where creating a copy is expensive. With that in mind, let's consider a scenario where the argument is not a variable, but a value such as a constant, literal value, or a value returned from a property accessor or method. Since these values do not have a memory location that can be directly referred to, the compiler creates a new temporary read-only variable and passes it by read-only reference to the method. However, this approach goes against the optimization reasons that lead us to use the pass-by-reference technique in the first place. By using the in modifier in the method call, we can avoid this extra step of creating a temporary variable. Okay, to summarize, if we don't use the in modifier in the method call for non-variable arguments, a new temporary variable is created. This can affect optimization and performance. On the other hand, if we use the in modifier, we can optimize the method for variable arguments. However, if we try to use it with non-variable arguments, we'll encounter an error. Alright, another point to consider is that we can make the ref modifier read-only to make it behave like the in modifier. In this case, when using in or read-only ref, we cannot change the value of the parameter. Additionally, in the method call, we can use either the ref or in modifier. Okay, done. See you soon.